So this whole story begins with a right triangle, and it always has to be a right triangle. You can tell when you have a right triangle because they're going to put a little box in the corner. And what that box means is that this is 90 degrees. So you have a 90-degree corner, and the other ones obviously are not going to be 90 degrees then. And so your two sides that are connected to that 90 degree, so the two sides, this one right here and this one right here, that's what makes that 90-degree angle. Those are called the legs of the triangle. All right, those are the legs of the triangle. Now you have another side, and this side is pretty special. So this side right here, this one is not attached to it. It's going to be the longest side always. And this one is called your hypotenuse. Now, when we're talking the Pythagorean theorem, we actually make this a bit simpler than just leg, and hypotenuse. What we do is we label them A, B, and C. C is usually reserved, or almost always reserved, for the hypotenuse. A is reserved for the length of one side and B for the other side. The cool thing about A and B, though, some people get confused because like, which one's A, which one's B? The cool thing about it is it doesn't really matter, actually, as long as they're the sides and not, or the legs and not the hypotenuse. It really doesn't matter which one is A and which one is B. So I could totally switch these, and I could put B on the side and A on the bottom if I wanted, and it's still the same thing. And so the reason it's called Pythagorean theorem is because there's this guy named Pythagoras that discovered this. And what he discovered is if you have a right triangle, so you have a right angle there, if you were to take this side A and put it along the side here and actually make a square out of it, okay, so that means that this side is A also, then the area would be A squared. So A squared just means you have that many A's, or squares, so you have A squares along the one side and A squares along the other, and then, you know, this whole thing is filled up with A squared blocks. Okay, then you have B, so this is B, and then we can make a square here out of B. And so then we have here B, and you have blocks here also, there's B of them, B squared of them, sorry, B squared. So what's cool about that is if you were to take all the blocks from this one and all the blocks from that one, and you put them over here and started building it off on C, so all of them from A, all of them from B, you would actually make another square, and this square would be C squared. So you're taking all the squares from the A one and all the squares from the B one, you're adding them together and you're putting them here, and they make up this entire square right here of C squared. But that only works if you have a right triangle. If you don't have a right triangle, then you can't do this cool thing. So the formula, the theorem, then is A squared plus B squared equals C squared. You know how we use the word squared for that exponent of 2? That's because it actually physically makes a square when you put it out with blocks. So what's happening is you're going to be given a right triangle, and you're going to be told two sides, and you need to find the third side. So the simplest one is if you had the two legs, and you need to find the hypotenuse. And so then what you would do is pick which one for A and which one for B. It really doesn't matter which is which. I'm going to put A as 3. And so I'm going to plug in 3 for A, so that means I have 3 squared. And I'm going to plug in 4 for B, so that's 4 squared equals C squared. And now what's cool about this, I only have one variable now. See, I have that C right there. It's only one variable, and I can solve this. So I have 3 squared is 9, 4 squared is 16 equals C squared. Add those two together, 9 plus 16 is 25. And if I want to know what C is, all I have to do is square root both sides, and I get 5 equals C. And so now I know what C is. Another way that that could happen is, I'll write it down again. Maybe instead of two legs, you're told one side, one leg, and then the hypotenuse, and you need to find the other leg. So it's just really important here that when you plug in 13, you plug it in for the C value. Don't get in the habit of always plugging in for A and B. So let's say A is 5. B, we don't know it, so we'll just leave B. And then C is 13. And then I just go ahead and use my algebra skills. So 5 squared is 25. 13 squared is 169. And then we start solving, so I need to move the 25 over, so I'll subtract 25. So then B squared equals 144. And then we square root, and B equals 12. So that means this is 12. Now, I purposely picked examples that came out perfectly. Sometimes you're going to get down to where B squared equals 91. And then you don't actually know the square root of 91, so we square root it. And I don't have a square root of 91, so we just say that B is the square root of 91. Or if the instructions tell you to go to 2 decimal places, then you'd plug it in a calculator and figure out what it is. So don't get freaked out if it's a number that you can't square root. You just write down the answer as the square root of that number.